Hello, good morning. My name is Kenneth Chow or Man Chow. This is my quantum gravity wheel number 15 of my series. In this series, I'm going to interpret how electromagnetic forces, that is either forces, electric or magnetic forces, are produced by moving charges. I have a diagram here. So first take a look at it. Before I explain, if for a charges moving from along the x direction, first I have to explain that this figure was taken from page 20, chapter 20, page 20 of Feynman's lecture. That is that's when a charge is moving along the x-axis. First have to have a coordinate system, x, y, z, and then it's moving along the x-axis. Then it will produce a electric field, phi, which is phi, represented by phi. The Greek letter will be produced, and this magnitude of its phi, x, y, z at the point x, y, z is equal to the charge divided by 4 pi epsilon naught and times 1 divided by x squared plus y squared plus z squared to the power 1 over 2. That means the square root. This is just Coulomb's law. As we see, we're looking at this Q. Now it's in a moving coordinate system. So under the Lorentz transformation, x will becomes x minus vt, that is the velocity of the moving charge, times time, that's the time under which the charge has moved, divided by the square root of 1 minus v squared divided by c squared. This is a Lorentz transformation of the x, or the charge moving in the x direction. There's no nothing. There's no change in the y and z, because it's not moving in either of these directions. And therefore the equation actually becomes this: phi x, y, z, t time is equal to q divided by 4 pi epsilon naught times 1 square root 1 minus v squared over c squared, and times 1 over x minus v squared v times t divided by 1 minus square root 1 minus v squared over c squared, all square, plus y plus z all to the power 1 over 2. That's the square root. I mean, 1 to the power 1 over 2, it means the square root. A square root over all this sum. That is the that is means that it has whenever the charge moves, you will thereby generate a field. The field will become this way. And before it moves, when it's at the origin O, you will have just the Coulomb's law, a familiar Coulomb's law expression. Phi x, y, z is equal to q plus 4 pi epsilon naught multiplied by x squared plus y squared plus z squared, all square root, all to the power 1 over 2. But here you have to note that the Q is elementary charge 1 over 1.602 times 10 to the power minus 19 Coulomb for electron. Negative or positive for a proton. The same charge for a proton and electron. Well, but one is negative, one is positive. And then you have also to note that for an ordinary object, we are now talking about a single charge, but for an ordinary object, there will be the number will be involved. It will be a multiple of 6.022 times 10 to the power 23. That is the Avogadro number. However, as most of the charges are normally cancel out, they cancel out. Because why? Because they're due to their opposite orientations within the object. They will have a different opposite of orientation because of the number. The number is so big that most of them will have a opposite orientations in the atom, more specifically a hydrogen atom. Therefore, the object normally appears to be neutral in charges. But however, when both objects start to move relative to one another, or when one of them moves, then there's the motion relative to the other. Then there will be an electric field and magnetic field. And this is the origin of the phenomena of gravity. That's the point I want to emphasize. Now I come to the actual operation of gravity. The actual operation of gravity comply with our familiar laws of physics, that is to say, statics and dynamics. This is not surprising because gravity is usually considered in connection with macroscopic objects, from the tiny objects such as those of 1 to several millimeters diameter to gargantuan astral objects such as the moon, the sun, and the planets, and bigger still such as the Milky Way and the Andromeda. Now we consider the most familiar ones first. The A, the objects near the surface of the Earth. I will refer to a book by an Australian physicist, Mr. K.E. Bullen, which is a 1983 edition book called The Introduction to the Theory of Mechanics. And on the from 194 to page 197, it says, forces on the systems of particles will result ultimately in a resultant of A single localized vector, and a couple of moments, both of which are uniquely determined. They are not arbitrary, they're uniquely determined. Or another situation is zero. There's no single vector and no couple of moments, just zero, nothing, zero gravity. That's in the case of objects falling under a near surface of Earth, then you have this. The object will have a single vector towards the Earth, and it also has a couple of moments making it turning somersaults, as you say, when it falls. But for an object which is very near to the surface of Earth, then there's no time for it to turn somersaults to exhibit the couple of moments. For example, this, when it falls, it just falls. It seems to just fall with a single vector and have no time to exhibit the somersault behavior, because there's no time. But if for an object falling from a very high altitude, for example 10,000 feet, then you will notice that it turns somersaults as it falls. B, you have the moon, the Earth, and the Sun. Let me see this first. I then have to explain. You will also have a single vector, the moon, towards the Earth, and you will also have a couple of moments. One falls towards this side, one towards this side at a distance. This is also called the arm of the moment of the couple. Arm of the couple. And then this moment will cause the moon to spin when it revolves around the Earth. And then the distance, what's the arm of the moment of the moon revolving around the sun, around the Earth, it will be equal, is in inverse proportion to the masses of the two astral bodies. The Earth, as the Earth is 81 times the mass of the moon, that is the common center of masses inside the Earth. There's somewhere in the mantle, in the Earth's mantle, it's about 4,000 kilometers from the center of the Earth. It's in the mantle, below the Earth crust. Therefore, the moon appears to revolve around the Earth. But actually, both the Earth and the moon are revolving around the common center of mass of the two objects, the two astral bodies. Similarly, for the Sun and the Earth, it's just the same situation. But as for the only difference is that the Earth is 81 times of the mass of the moon. But for the Sun and the Earth is only, the Sun is about more than 900,000 times the mass of the Earth. So you see when that's in inverse proportion to the mass, then actually the common center of mass of the Sun and the Earth is somewhere near the center of the Sun. So actually the Earth does revolve around the Sun. or almost revolve around the sun. Actually, but also actually very precisely, both the sun and the earth are revolving around the common center of mass only. Not the earth does not revolve around the sun, but revolve around the common center of mass. Oh, the first situation C is at 0, where the 0 gravity situation. While you have in the spaceship, while the spaceship revolves around the sun, just as the moon revolves around the sun, almost revolves around the sun, an astronaut inside the space station, which is much more smaller than the space station itself. So we have a 0 gravity. So it floats around. You see the astronaut floats around in the space station because there's no single vector towards the sun, towards Earth, or nor does it have a couple of moments which will cause it to turn or spin. You don't see the astronaut spin in the inside the space station. Now I come to the something which is my own invention, just my own design. It's called the Newton-Coulomb Planck Formula. It means we have using this formula. What is the purpose is to show that the when we convert all masses to Planck mass, and when we convert all lengths to Planck lengths, and then that is to say that when the masses and lengths are quantized, then there is no difference between the electromagnetic force calculated under the Coulomb's law or the gravitational force calculated under Newton's law. So I've demonstrated first. When Q1 and Q1 means the charge, all the charges on the sun. Q2 means all the charges on the Earth. I'm talking about the Sun-Earth situation. And then first by one, the video 13, video 13 number 1 of my video 13, you have this the Q square is equal to 10 to the power minus 20 to the power 7 times the mass times the length, that's the wavelength of the radius or whatever, and times alpha, that is the find constant constant, this one. I will show you that there's no need in the situation to add alpha, because alpha is only required to multiply alpha is only required to convert Q square to something, to mass and radius, the product. When this conversion is not necessary, there's no need to add alpha. So using the equation 1 just mentioned, Q1, Q2, 4 pi epsilon naught r square, and then by 1 of video 13 is just equal to mass of the sun times mass of the Earth times 10 to the power 7 divided by 4 pi epsilon and r square. R square means the distance between the sun and the Earth, which is the distance between the sun and the Earth is 1496 times 10 to the power 11 meters. This is in meters. Yes, I got this from the book called The New Solar System. It's figures. And the sun mass is 1.989 times 10 to the power 30 kilograms. And the mass of the Earth is 5.974 times 10 to the power 24. Yes, I got it from the book called The New Solar System, but actually in all astronomy books, they're more or less the same. And so you have 1.989 times 10 to the power 30 times 10 to the power 9474 times 10 to the power 24 divided by 2.177 times 10 to the power minus. What's that? That is the Planck mass. And the 10 to the power 7 is equation 1. Yeah, the 10 to the power 7. What's the 10 to the power 12? 10 to the power 12 is from the denominator, the epsilon naught. Epsilon naught is 8.854 times 10 to the power minus 12. So what is in the numerator is minus 12. 10 to the power minus 12 becomes 10 to the power 12 in the numerator. What is in the denominator becomes 10 to the power 7 in the numerator. So this multiplied by the R square means 1.496 times 10 to the power 11 all square divided by 1.616 times 10 to the power minus 35. What's that? That's the Planck length meter. 1.616 times 10 to the power minus 35 meter. So the whole thing worked out to be 35.42 times 10 to the power 21 newtons. It's a force. The gravitation is magnetic force, electromagnetic force. Now, next we use the Newton's force. Newton's equation. G is familiar. G m1, m2, the mass of the first body, mass of second body, the R square. So G is 6.673 times 10 to the minus 11. Its unit, very strange, is called Newton meter square per kilogram square. Multiply the sun's mass is above, and then the Earth's mass is above, and then the divided by the R square, the distance between the sun and the Earth, the 1 AU, 1 astronomical unit, 1.496 times 10 to the power 11 all square. So that's the final answer is just 35.42 times 10 to the power 21, the same. But when you work out in under the Coulomb's law, the electromagnetic force, and under the gravitational force, it's the same. Next, we come to use the sun mass, the mass of the red planet. By the same procedure as above, just simplify this, not to repeat. Q1, Q2 is equal to 1989 times 10 to the power 30 times 10 to the power times 6 to the 0.42 times 10 to the power 23. That's the mass of the mass. I also get it from the introduction to New Solar System, the starter. And the 2.1 divided by 2.177 times 10 to the power 8 is Planck mass, and times 10 to the power 7 is from equation 1 of video 13, and 10 to the power 12 is from the epsilon naught in the denominator. The denominator is in the denominator 10 to the power minus 12 becomes 10 to the power 12 in the numerator. And finally, we have the 2.2794 times 10 to the power 11. What is this? This is the distance between the sun and the Mars. The average, actually, must be said as average, is because the mass is not constant, so it's of the same length. This is average distance between Mars and the sun. divided by 1.616 times 10 to the power minus 35, the Planck length. And what's the final answer? Is 1.64 times 10 to the power 21 newtons. Next, using Newton's law. m1 mass of the sun, m2 mass of Mars, divided by the distance between the sun and the Mars, and you got 146.673 times 10 to minus 11, just the same. And then the sun's mass and the Mars mass, and the distance between the sun and Mars, it's all square. What's the final answer? Also 1.64 times 10 to the power 21 newtons. Finally, I have repeat. Sorry that I have to repeat 3 times. The sun and Mercury, and the same procedure as above. So you got Q1, Q2, and 4 divided by 4 pi epsilon naught square all out square, and then this is the 3.3, 1.989 times 10 to the power 30 is the sun's mass. 3.3 times 10 to the power 23 is the Mars mass, and this is 2.17 times 10 to the power minus 6 is the Planck mass, and 10 to the power 7 from the equation 1, 10 to the power 12 is from the 8.85 in the denominator. What is 8.854 times 10 to the power minus 12 becomes 10 to the power 12 in the numerator. And what is the 5.791 times 10 to the power 12, the power 10 to the power 10, it is the Mercury's mass, and divided by 1.616 times 10 to the power 35. This is the, oh no, this is not the mass, this is the distance between Mercury and the sun. I also got it from the introduction to the new solar system. And then what's the final answer? 1.3606 times 10 to the power 22 newtons. You notice that the gravity force between Mercury and the sun is stronger than the gravity force between the Mars and the sun, and also stronger than the gravity force between the sun and the Earth, because it's much more nearer to the sun. Using Newton's law, G times mass of sun and mass of Mercury divided by the distance between sun and Mercury. So you got this mass of sun, this is the mass of the Mercury, and the distance between sun and Mercury. So it's again it's 1.306 times 10 to the power 22. So I hope that by repeating this unnecessarily, repeating this calculation for the astral bodies, for the sun Earth, for the sun Mars, and the sun Mercury, and I have finally convinced you that when the mass and length are converted to Planck mass and Planck length, that is, when this mass and length are quantized, there is no difference between the electromagnetic force under the Coulomb's law and the gravity force under the Newton's law. That is, they are both unified. They are both unified as parts of the quantum gravity. I think I have to stop here. And a very Merry Christmas to you, because today is 24th of December.